Okay, so what we're going to do is we're going to put all of these theorems and all of these rules together, and you are actually going to solve for all the zeros of a polynomial. So step one, you're going to use the degree of the polynomial to determine the max number of zeros, real and imaginary. So if the degree is 4, there's going to be 4 possible zeros. If the degree is 7, 7 possible zeros. So you're going to look at the degree first. And then after that, you are going to use the Descartes rule of signs. Oops. Use the Descartes rule of signs to determine the number of possible positive real zeros and negative real zeros. You can do the positive, negative, imaginary chart. So this is an important step because if you do the Descartes rule of signs, it's kind of going to cut down on how many times you're going to have to test rational zeros. And I'll actually show an example in a minute. Let's go ahead and look at step 3. If the polynomial has integer coefficients, use the rational zero theorem to identify the rational zeros that can potentially be zeros. That's the P and Q stuff. And then here's where all the legwork comes in. We are going to use synthetic division to test each potential rational zero. If you go to step 2, always do step 2 because it's going to cut down on some unnecessary work on step 3, and I'll show you why in a few minutes. Step 5 is going to be each time that a 0, which is also going to be a factor, is found, you're going to repeat step 4 on the depressed polynomial that's just down by the degree. That's the answer. That's the quotient. Note you could redo steps 2 to 4, but it is not necessary. What I'd like to add to that is once you find a rational zero and you actually find that it's a factor, you need to see if this is factorable. Remember, factoring is king in this module. If I have a depressed polynomial quotient that's factorable, then I don't need to test anything. Factoring is going to reveal what the real zeros are. Step 6, in attempting to find the zeros, remember to use, if possible, the factoring techniques, which is what I just talked about. Special products, perfect squares, difference of squares, factoring by grouping, that's going to be a big one here in just a few minutes. On number 7, once you reach a depressed polynomial that is a quadratic. In other words, once you factor down and you get to a power of 2, if you cannot factor it, you're going to have to do the quadratic formula or complete the square to find the remaining zeros. Okay, so that's going to be the steps. Make sure you write all of those in, and we'll actually look at an example now.